Hello everyone. Today's topic's name is linear dependence and independence of vectors. Before going to this topic, at first you have to know the echelon form or echelon matrix. A matrix A is an echelon matrix if the number of zeros preceding the first non-zero entry of a row increases row by row until only zero rows remain. That means if in a matrix the number of zeros uh, increases sequentially, then that matrix will be called echelon matrix. It is also an echelon matrix or echelon form because here the there are two zeros, and in the third row there are three zeros, and then all are zeros. So the number of zeros are increasing sequentially. Here also there is one, there is two, here there is three zeros, and here all are zeros. So the number of zeros are increasing sequentially. That's why this form is an echelon form and this matrix is an echelon matrix. Now come to the point linear dependence and independence of vectors. Here given the definition, let V be a vector space over the field F. The vectors v1, v2, v3, vm belongs to V are said to be linearly dependent over F or simply dependent if there exists a non-trivial linear combination of them equal to the zero vector 0. That is, if alpha 1 v1 plus alpha 2 v2 alpha 3 v3 alpha m vm equal to 0, where alpha I not equal to 0 for at least one I. Here alpha are the scalars that has been taken from the field F. F is a set of scalars and the vector space V is a set of vectors. Here v1, v2, v3, vm have been taken from this vector space V. On the other hand, the vector v1, v2, v3, vm in V are said to be linearly dependent over F or simply independent if the only linear combination of them equal to 0 is a trivial one, that is alpha 1 v1 plus alpha 2 v2 alpha 3 v3 alpha m vm equal to 0 if and only if all the alpha is 0, individually 0. So in both the cases, linear combination is 0, but here at least one alpha is not equal to 0, but for the linearly independent case, here all the alphas are 0. Here given a related problem, we have to prove that the following set of vectors is linearly dependent. So at first we have to generate the linear combination. Uh, Here it has been made. Set a linear combination of the given vectors equal to 0 by using unknown scalars x, y, z. Here it could be taken alpha 1, alpha 2, alpha 3, but here it has been taken x, y, z, similar. So the scalars have been taken x, y, z in terms of alpha 1, alpha 2, alpha 3. Anyone can take alpha 1, alpha 2, alpha 3 instead of x, y, and z. Anyway, we have to generate the linear combination x into this first vector 2, 1, 2 plus y into 0, 1, minus 1 plus z into 4, 3, 3 equal to 0, 0, 0, because every vector is containing three tuples. So in the right side, the 0 vector, here also there are three tuples, 1, 2, 3. Now, if we multiply these AB tuples of this vector by x, we get twice x twice x, 0, y minus y, 4z, 3z, 3z. And uh, from this, we get, if we take the of addition uh, from every vector, the first tuples twice x plus 0 plus 4z, then x plus y plus 3z, twice x minus y plus 3z. Now, if we equate the corresponding components from both the sides, we get the system of linear equation, that is twice x plus 0 plus 4z equal to 0, x plus y plus 3z equal to 0, twice x minus y plus 3z equal to 0. So we get the system of linear equation 1. Now we have to reduce this system into echelon form. We can convert this system easily into a matrix. If we write this system into a matrix form, then the first row components will be 2, 0, 4, second row 1, 1, 3, third row 2, minus 1, 3. So anyone can convert this system into a matrix to reduce this into echelon form. But here it has been done in this system of linear equation. We have to reduce this system of linear equation to echelon form by the elementary transformation. Elementary transformation means the operations, interchange, addition, subtraction, multiplication, division, all the operations to convert it into echelon form. These operations are called elementary transformation. So first elementary transformation has been taken, interchange first and second equation and get the equivalent system. So at first we have to interchange the first and second equation. So if we interchange, the first equation will be x plus y plus 3z, and second equation will be twice x plus 0 plus 4z equal to 0. This, and third equation will be remain same. So this is system 2. Now, to convert this system into echelon form, we have to uh, make these first components 0. So to make it 0, here the operations have been taken L2 prime equal to L2 minus twice L1. That means L2 prime, that is new L2, new line. So uh, we have to multiply the first equation by 2, then have to subtract from the second equation. And the second operation, L3 prime equal to L3 minus twice L1. That means we have to multiply the first equation by 2, then we have to deduct from the third equation to make the first component 0. So after operation, we get this. Now to make to do simplification on this system, the further operations have been taken. The second equation uh, has been divided by 2, minus 2, and the third equation by minus 3, and then the equivalent system will be this. The first equation will be intact and second equation will be y plus z after division by 2, and the third equation will be converted y plus z after division by minus 3. And we observe that the second and third equation in this system are same. So if we deduct third equation, uh, if we deduct second equation from the third equation, then this third equation will be vanished. So the reduced system of linear equation is this. So if we convert this system into matrix form, then we get 1 1 3 0 1 1 0 0 0. That means this 1 1 3 0 1 1 0 0 0. That means this is echelon form, because here the number of zeros has increased sequentially row by row. So this system has been reduced in the echelon form, and we observe that here there are two equations in three unknowns. So to find a solution from this system, we have to take uh, a, a free variable. We have to let a value for the third variable, say z. That means if we take z equal to 1, then we get y equal to -1. And if we put the values of y and z in the first line, then we get the value of x. So to find the solution from this system, we have to let a free variable. That means this is not a zero solution, hence the system has non-zero solution. So if we it is not trivial solution. Trivial solution or trivial case is if we got all the values of the variables are zero, that time it would be trivial case. But here we get non-zero solution, so it is not trivial, and that's why the original vectors are linearly dependent. If we would get all the values of the variables are zero, that time it would be linearly independent. But here we get non-zero solution. That's why we the original vectors are linearly dependent. So it was that's all for today. Thanks to all.